All right, so somebody wanted to see 103 from the homework, so let's look at that. We've got 2 plus root 2 plus root 7, and can we have radicals in the denominator? No. So we have to multiply by the conjugate, which is going to be root 2 minus root 7 over root 2 minus root 7. What's that actually like we're multiplying by? 1. Why do we have to multiply by 1 in this weird form? Because it doesn't change the what? Value of what we started with, okay? So, folks, some of us had trouble, and it's apparent on the quiz that when you see this right here, you've got to distribute, folks. And when you see this right here, you got to FOIL. Whenever you see a binomial times a binomial, you've got to FOIL that thing out. Now, this is a special case when we get to do a little shortcut. 2 times root 2, 2 times, let me write this out. Hold that thought. You don't have to write this out this way, but I am for instruction purposes. Because you need to see that you're going to distribute. You need to see that you're going to FOIL this out, okay? Here we go. Now is when we get 2 root 2 minus 2 root 7. Leslie, does that help? Okay. Over, this is where we get to do the shortcut. First and first, last and last. Right on? So root 2 times root 2 is square root of 4, which is actually just plain old 2. Square root of 7 times the square root of 7 is the square root of 49, which is plain old 7. And this was the different little twist where our answer was different from the back of the book. The way we look at this, we've got 2 root 2 minus 2 root 7 over 2 minus 7 is negative 5, right? Right. And what it was that negative 1 thing. It's that negative 1 that continues to haunt us. If you put it in a calculator, though, their value will match our value, and it's all good. I'm fine with you leaving it like this. I'm even fine if you were to factor out a 2. And if you had that right there, that's fine as well, okay? No, it had to be negative. Had to be negative. Absolutely, I'll do that one. All right, does that help? Kinda. Where are we losing? Where are we distributing FOIL here? If I were to change this to look like this, 2x plus y, x plus y, x minus y. This is just thinking, okay? Would you know what to do there? Okay? Don't let that radical throw you. That's the same thing as the quantities, and when we were going over those really tough factoring problems. Don't put it into terms that you're comfortable with, okay? If we take it back to something like Algebra 1, and this is Algebra 1, then you'll know immediately 2x plus 2y, got it, right? And you can look at that and you know it's going to be x squared minus y squared. And the twist here, the thing, is when we've got those radicals, things change a little bit. Because radical 2 times radical 2 is radical 4, which simplifies to plain old 2, right? Okay, questions? Does that help? Yeah. Okay. Go back to what you're familiar with. You don't need that. You do need this. Was it 95? Okay. 95, let's look at that one. All right. So we're looking at this problem, and that is definitely a complex fraction, isn't it? When it's got that many fractions within a fraction, that makes them want to cry. But I'm going to rewrite this how? What do I call it? Oh, come on. Thank you. Write it old school. Numerator divided by denominator. Okay? And then it's two separate problems. Two separate problems. Look what we're going to have. Take care of the first one. This is like order of operations on steroids. Because we have to take care of one set of parentheses, and then we're going to take care of the other set of parentheses, and then we're going to bring it together, and we're going to have to do a whole nother problem. Okay? What are we going to do with the first set? We've got to have like denominators. What's my common denominator, folks? XY. All right? XY, XY. What did I multiply to the first one? X. So I have to multiply another X to the top. So X times X is X squared. Is everybody with me why I've got X squared? Everybody cool? If you're not, you better say so. What's going to be up here in the top of the next numerator? Y squared. Because Y times Y is Y squared. What's my common denominator for the second set of parentheses? X squared, Y squared. Good. What's in my numerator? Y squared minus X squared. Y'all with me? Okay. Keep going. We've got X squared minus Y squared. What am I doing? No, I wouldn't call this combining like terms. What am I just doing? I usually say the same thing over and over again. Say it. I think you're saying it. Am I making it one numerator over one denominator? Because combining like terms to me would be adding a plain old X with another plain old X. Since these aren't the same, I just have to kind of smash them together, right? Divided by Y squared minus X squared over X squared Y squared. Again, just making it one fraction divided by one fraction. Okay? Now, does anybody see anything going on here that kind of looks similar? They look, yeah, something's going on. Zach, what you see? What did I call? This is never, if you ever find this in a book, in a math textbook, y'all better call me, find me, show me, because if somebody takes this from me, I'm going to sue them and I'll be a millionaire. What do I call this? They look alike, but they don't, but you know they're kin. They got to be cousins, right? So what am I going to do? I'm going to go ahead and do what with this X squared minus Y squared? What? What? I heard 14 things. Say it again. What am I going to do? Cindy, what am I going to do? I could factor out the -1 there, but this looks normal to me. X squared minus Y squared, that looks okay to me because it's in alphabetical order. What else could I do to that? I'm not going to take out a -1 yet. I'm going to hold off for just a second. What else could I do with that, folks? Oh, could I factor it? It's a difference of squares. Could I not say X minus Y, X plus Y? Can I just factor it out? Because it's a difference of squares, right? You know I'm going to do something with that -1 thing, but I'm not going to do it yet. Because I'm going to force you to do this. Can you factor Y squared minus X squared? What? Yes, you can. We don't like it because it's not in the right order. But how would I factor that? Y minus X, Y plus X, right? Now I'm going to factor out a -1 here in just a second. What am I going to do? I've got a division problem. What am I going to do? Copy, change, flip, which is what you would hear in elementary school. We call it what? Multiplying by the reciprocal, right? Because we've got to make it sound like we're fancy. We're not fancy. We just think we're fancy. Here we go. This is trig. That's right. Still, I haven't changed anything around. Now what? We copy, changed, flipped, but we didn't really do that. We multiplied by the reciprocal. What now? Now you want to factor out the negative 1? All right. Where am I going to factor that negative 1 out from? Where's it going to come from? The y minus x? That's the one that it's got to come out of. Watch, and I know I'm creating like 3 steps when some of y'all are going to go straight to the step number 7. I don't care. Here we go. Factor out a negative 1, and I want you to think. Negative 1 times what gives you positive y? Negative 1 times what gives you positive y? Negative y. Okay, here we go. Negative times a negative is a positive. That's right. Negative 1 times what gives us negative x? Positive x. All right, let's just check it. Negative times a positive is a negative. We're good with that. Can I do anything with the y plus x? Why is it okay for me to switch that one around and I don't have to factor anything out? Because they're just both positives. It's all right to switch those around. So we're switching. What now? I still got to write that. I got to write this one more time, y'all. I have to do it. You guys will not, I know, 3/4 of y'all will not write this step. Probably 7/8 of y'all will not write this step. Probably no one will write this step other than me. I've got to write that thing. I got to fix it. Got to fix the way it looks. Now what? Now can I get my Zorro sword and go and start marking stuff out? Y'all don't even know who Zorro is, do you? Do you know how many of y'all know who Zorro is? How many of you have seen the original Zorro films? Shows? High five in the air. You know he did the Z? Y'all know he rode a horse? Okay, yeah. All right, what am I going to do? Thank you, Ebony. Cancel out what? I'm sorry, I was distracted. Say it again. The x minus y's. The x plus y's. Stop talking. I'm going to throw something at you. What else? Oh, the x's. Here's where some of us have got to be very, very careful, because on your quizzes, some of you made some careless mistakes, and I just wanted to go, oh, no, you should not be making these mistakes because they're careless. X goes into x one time. How many's going to be left up here? This is the part you forget. Or you would do all of the canceling out, and then guess what you'd forget to write down? The x and the y. And I just wanted to go, elbow drop. What's left in the numerator? xy over negative 1. Ooh, that looks weird. How can you fix it? Just divide. What's a positive divided by a negative? Negative. Now better. I still don't like it, but it's better than it was. Cool? Did you find your mistake? Yeah? I will be happy to help you, but you need to work towards these answers. I expect, listen to me, I need to see your eye peepers right here, okay? I expect you, if you got some of these wrong, to go back and work until you get the right answer. I will help you, you know that. And if you've ever been in here in the morning, you know if I have time and don't have 43 other people in here, I want to help you. But you got to help yourselves. You got to help yourself, okay? Here's what you're going to do. Number 1, you're going to work towards these if you didn't get them. A times a minus 1 over 2 times a plus 1. Write these down. Oh, look, I'll break into Georgia Strait. All right, here we go. Write this down. B times the quantity B minus 1. Number 3. These are the answers. Some of you, for number 3, you had 2x plus 5y. That was totally fine. Commutative property of addition says that it's okay to switch those around. And then number 4, y'all's number 4, ends up being this thing right here. X squared minus x minus 5, all of that over x times the quantity x minus 1. So, yeah. Look at it. Think about it. Still, any burning questions? Yes, these are the answers to the quiz. Let me make that clear. My fault. These are the answers to the quiz. Go back and work these out. Any questions that you like, I got to know how to do this. Please go back and work those out. Going. I feel like it's an auction. Going. Do you want me to work one out for you? Work out number 3 and number 4. Here we go. Bless you. All right. Some of you are you a multiplier? Do you multiply who asked for 3? Do you multiply your denominators together and then simplify at the very end? You just kind of look at it and figure it out. Okay. Sometimes we just have brain farts, and that's all right. But this is what I would do. I got x squared over here. I got an x here. Which x do I take for my common denominator? The bigger one. I always take the bigger one, so x squared. I got an x squared. I got an x cubed. Which one do I need for my common denominator? The bigger one, which is cubed. If they're already in both denominators, you've got to choose the one with the bigger exponent. Okay? And then, all right, we got a 5 already there. We got a 2 already there. What am I going to... This is the weirdest thing I've ever seen. And I'm not going to let it bother me anymore. Y'all know I am not making them squiggle marks. Y'all know it bothers me badly. I am not, Logan, I'm not making them squiggle marks, okay? You know that I'm not doing it. There's a ghost in this board. What did I multiply to this denominator that I have to multiply to the top? What's different? I got x squared, y to the second, y to the third. What do I need to multiply to the top? A y. I got x squared. Ooh, what am I going to multiply to the top? X. My y's stay the same. What am I ready to do now? Write this as one fraction over one numerator over one denominator. Okay? So here we go. Just put them this. One numerator over one denominator. Can I literally combine to get this right here? Not that. Can I do that? Why can I not do that? Why can I not do that? They're not like terms. No. 5 yaks and 2 xylophones do not mix. You cannot create 7 xylophone yaks. Can we, MC? Have you ever seen a xylophone yak or a yak xylophone? No. Don't do it. This is it. That's all I can do with that. That's it. I'm sorry. Do what? I'm all right. I'm just trying to help you understand. Number 4. Oh, where's y'all's number 4? Here we go. What are we going to do here? Talk to me. Tell me. It's important that you know how to do this because you're going to have a test on this on Friday. Common denominators. Before I know that, but what do I have to check on? What do I have to check first? Check the denominators. I got an x, and then I got this thing right here. Folks, this is not a difference of squares. X squared minus x. What's the first thing you factor out always? A GCF, which is x times x minus 1. It is not x times the quantity x minus x. What is x minus x? Don't make fun of your teacher. That does kind of look like, that's the way I felt grading this. What? That's the way I, look at that face, y'all see it. What's going on? Can't you see? I could hear myself. What is going on? No. You're a weirdo. Here we go. Say that with love. Okay, we got x on the left. We got x times the quantity x minus 1. What is the denominator? It's this thing over here. X times x minus 1. Now I'm just saying, does the rational expression on the right, does it change at all? Does its value change? No. So I'm not going to change that denominator. Oh yes, this bit many of us. What did I multiply to the denominator? X minus 1, which has to be multiplied to the top. Don't forget about what's already there. And it's a binomial. It is not x plus 2 times the quantity. It's a binomial times a binomial. What do you have to do with this first numerator? FOIL it out. Ugh. X times x is x squared. X times negative 1 is negative x. Plus 2x minus 2 minus the quantity. All of this over one denominator. Folks, you better look at that. And I think I wrote on people's paper, you just got bit in the booty. What did people get bit in the booty? Bitten in the booty would be proper. I need to ask Miss Turner that. The proper grammar for bit in the booty. No, just kidding. Focus, focus. You have distracted me with your snow talk, ice talk. Stop it. What do I have to do? It's bad when your teacher has to tell her own self to focus. So I need it. Hold on. Here we go. See how much better your teacher is? What's going on with minus that quantity 2x plus 3? You can't forget about that. Folks, I'm going to rewrite this 100 times if I need to, so I do not make a careless mistake. I cannot stand making a careless mistake. If one little sign problem causes me to get a whole problem wrong, I want to fight. I'm like, what am I doing? I can't stand them. Negative 2x minus 3, y'all. Now look at it. All that junk in that numerator combined like terms. I've got an x here, got an x here, got an x here. Plain old number, plain old number. Okay? Bring down x squared. Negative 1 plus 2. That's going to be negative 1x. Minus 5. Okay. Negative 1, positive 1, negative 1. Back to negative 1, right? And then just to clean it up, I don't care if you'd left it like that. But I think this is what I wrote on the board earlier. Okay? Think about this stuff. Go back and work these problems. My intentions are for you to have a test review that I will hand out to you tomorrow. You'll work on it a little bit each night, or you won't work on it at all. Or you'll save it all till about 11 o'clock Thursday night, and then you're going to roll up in here all tired because you stayed up till 2 o'clock in the morning studying for your test. Or you're not going to study at all. Fart faces. Study. This is an advanced math class. Questions on this? You want me to tell you how I really feel? No, you don't. Yes, you would, because you just make fun. All right. Questions at all? Quiz okay? Work and get those answers correct. I triple dog dare you to. We are going to change gears again with this. This will go fast because this is still just the easiest thing ever. We're going to be solving quadratics by factoring and by the quadratic formula. Yes, you do need to memorize quadratic formula. What? I'm going to tell you in a minute. I'll tell you in a few minutes. But do you see what we're going back to? All right, we started with factoring. Then we went to rational expressions, which you had to know how to factor. Now we're solving quadratics by factoring. Hello. Guess it's important. Learn how to factor. You got to know how to factor. We'll keep going back to it. Factoring. Well, first of all, what's quadratic? What's quadratic? Seriously. 4, quad means 4. Good context clues. Not what I'm going for. Let's go down another path. Quadratic equation. How do you know if an equation is quadratic or not? It's a squared term. Somebody said it. It's got to have a squared term. It doesn't necessarily have to have 3 terms. Doesn't have to be a trinomial. Sometimes it's a binomial. Okay? But it has to have an x squared term. Now, when we solve by factoring, first thing you got to remember about these equations, it's got to be set equal to who? 0. Set the equation. Equal to 0. You do whatever you have to do to set that sucker equal to 0, okay? Write this down. It's important. Second thing, am I going too fast or am I good? All right. Second thing is you got to factor. Again, if you don't know how to factor, you up the creek. Third thing, set each factor equal to 0 and solve for the solutions. Is that rain or the air? I can't tell if I look out one window. It is. Okay. Wow, that's loud. It is loud. Okay. All right, so solving for factoring. By factoring, not for factoring. Solving by. Jeez, help me, Lord. All right, you got to remember that sometimes you have a no solution like you flat cannot get a solution out of there, okay? Or you'll get a non-real. Which includes the imaginary numbers. Includes that imaginary number I. And if you remember the no solution or the non-real answers, the quadratic does not touch the x-axis at all. Both of those. Just be aware of that. We may see those. Don't freak out if you do. Okay? Yep. Includes an imaginary number. Okay? Are we ready? Am I going too fast? Seriously. Some of you just are not even looking up. You're just like... All right, here we go. So we're going to solve by factoring. Unless this is so easy. Oh, my Lord, this is so easy. X squared minus 12x plus 27 equals 0. All right, is set equal to 0? Woo, good. Not yet, that's tomorrow. Not yet, hold that thought. Plus blank, it's tomorrow. Completeness square. What are we going to do? Factor it. Oh, I love to complete the square, it's easy. Oh, it's easy. Easy, easy, easy. We're going to put a blank in there on the left, we're going to put a blank on the right, it is all good. You'll see, you'll see. Promise, just have an open mind. Easy. Will this factor? Are there two factors of 27 that when you add give you 12? Oh, yeah. 9 and 3, right? Are my signs the same or different? Same. What are they going to be? Minuses. All right, now at this point, this is when we look at it and go, my solutions are 9 and 3. We don't literally set them equal to 0, and I don't care whether you write this down or not. But you do need to go back to Algebra 2 and remember that these are factors, which means that these are solutions. We had this discussion a lot in Algebra 2. All right, if these are the factors, then what are your solutions? Or I'd say, all right, these are your solutions. What are your factors? And we'd go back and forth because it's all over that SOL test. And it shows back up in trig. And it shows back up in math analysis. Guess it might be important, okay? Hey, remember you can write your solutions in them fancy brackets. In those fancy brackets, not in them. Cool? That's the answer. They are called the zeros. They are also called the what's? Roots. They are also called the x-intercepts. Solutions. Remember all those words we have to go through all the time? Yes. Questions at all? Could you feasibly know what you're going to get on a quiz on this material before you hand it to me? How? You can plug it back in. There's one other way. Somebody said it, I'm thinking. What? Say it again. Plug that in your calculator and find the what's. Zeros, folks. You can verify. Write this down. And notice that I'm putting verify in capital letters. You can verify your answers. With your calculator. Now, I know somebody's sitting there right now going, but what, so can I just put this in the calculator and write down my solutions? Yeah, you can. I will count off points for not showing your work. Is that being a fart face? Why, yes. Do I care? Well, no. I don't care. Do your job. You can verify with the calculator. You can't do all your work with the calculator. And I will tell you right now that you may come out of this class blowing up that calculator, but at some point that calculator's going to be taken away from you, and then you're going to be like, what do I do? And you're not going to know. So learn it. Learn it. Questions on this at all? Here we go. Here's another one. Up. What? Yep. Sorry. How do we verify? Get your calculators out. Oh, see, I just piqued your interest. Calculator. How do I do that? How do I check it? All right. Who's my back person? Who? Rachel. All right, if I ever use the calculator, somebody's got to come back here and cut it on for me. I don't know why. You just click on the on. But I can't do it from the board. I don't know why. I can use the calculator from the board, but I can never cut it on. All right, y'all ready? All right, Essence, let's see here. What was our formula? Not our formula, our quadratic equation. All right, so our quadratic's equal to 0, and that's where I want it, right? Go to y equals, cut your plots off. Y equals, I want to go x squared minus 12x plus 27, okay? The y equals acts as my 0. Then hit graph. Oh my goodness, my calculator screen is messed up. What shall I do? Zoom 6, zoom standard. Hit enter. Oh, I messed up. It's still running. What shall I do? Hit enter again. Aha. What are my solutions? 3 and 9, right? You can go to the table, but if you go to the table, you have to know that what value has to be 0. See, that's the thing. What value has to be 0 if you go to your table? Your y values have to be, so I always have to think about it. If you go here and find your zeros, go second trace. All right, let me back up. Hold up. Hold up. Hold up, hold up, hold up. If you'll just go to, look at it, eyeball it. Where does the quadratic, where does the parabola cross? Well, it crosses at 3, 4, 5, 6, 7, 8, 9. It looks like it crosses at 9. You can check your table. Oh. Up, 9 and 0. Remember, we're checking our zeros. Where's the other one? 3 and 0. Okay? I find the zeros, and I find the 0. My class, my oldies, we actually found the 0. Okay? So we go and we find 0, find the spider. Where's the spider? Nope, go this way. Okay, this is just another way to find the zeros. My spider has to be to the left of that 0. I hit enter. It has to be to the right. Hit enter. I don't want to guess. Hit enter again. 0. Boom, it tells you. And then I would go and do the very same thing for the 0 over here on the right, or the right root, whatever you want to call it. Okay? That is another way to do it. I don't care which way. Oh, what's the other way? You were the one that always said it, weren't you? What do we think the zeros are? We think the zeros, when we eyeballed our parabola, we think they're 3. Watch this. Well, my x value is 3. My y value better be what? 0. I think that the other x value is 9. Second calc. Let's see. If my x value is 9, my y value better be what? Hot dang. Look at there. Okay? Several different ways to find the same information. But you are going to do this to verify and not to solve for. Correct, gentlemen? Ladies? Right? Does that help? Okay? Let's look at another one. Here we go. Stop talking. What's wrong with that? Not equal to 0, so what do I need to do? Make it equal to 0. How? I got to add 36 to both sides. Are we cool now? Give me 2 factors of 36 that when you add give you 12. 6 and 6. My signs same or different? Same, they're both going to be minuses. Hey, my factors are x minus 6 and x minus 6. How many solutions do I have? I have 2, but we're only going to write it how many times? Once. The solutions are 6. We only write it once. Don't write 6 twice. But this is actually called, do y'all remember what we call it? It's a double root. Facile, difficile. Facile. Thank goodness, right? Ready for another one? Question? Yeah, it sounds like a cicada. Like another cicada going. I don't know. I don't know. Ignore that. Rewind. Don't listen to that. Here's another one. It's like a cicada that's being stepped on going, no. You know, they come every like so many years and they stay stuck. Their shells are left on the trees. Yeah, locusts. They're also they're called cicadas too. Yeah, they do. See? Every however many years. I don't know. Scariness. No, y'all, you've seen them. Time back in. All righty. Look at this. Sorry, I'm sorry. I can't help. Y'all, I seriously can't help it. What are we going to do? What's up, Christian? What's up with this? No. Not when we're factoring. We want it equal to 0. Don't forget about the GCF. Write this down. Don't forget about the GCF. There's a little twist here. We factor like normal. 2 times the quantity, x squared minus who? There you go. And then, are we done? Oh, we're still not done. What do we have to do? That's a difference in squares, so we're going to have x minus 5 and x plus 5. Okay. Let me ask you something. Are those my solutions? No. Why not? 2 is just a what? 2, it is just a number. But 2 is just a factor. Please write this down. 2 is only a factor, not a solution. It's a way for us to get to the answer, okay? Oh, Christian, were you thinking this? Were you thinking that? For real? For real, okay. You could have solved this problem that way. You could have done it that way as well. Promise. Okay, don't tell lies. He just lied. We all tell little lies and we don't mean to. I lie to my kids all the time. Shh, don't tell them. Thank you, Beth. You weren't forceful enough. Hey, are these my solutions? Yes? Are we cool with this? The 2 is just a factor. I wouldn't even include it. I would just do this, Chelsea. I would just write it like that right there. Okay? Why did Christian? Because remember at the beginning he said, I will add. Why do I want to divide by 2? No, you don't have to. No, if I set, remember the instructions say, factor, set each factor equal to 0, right? Does 2 equal 0? No, so that's why we're done. There's nothing else we can do with it except to solve, okay? That's why we don't include 2. Good, 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 good. All right. Hey, guess what now? Quadratic formula. We all love the quadratic formula. When do we use the quadratic formula? It's a last resort. It really is the last resort. Doesn't have to be. Because we use it as last resort when the quadratic won't factor. But the nice thing about quadratic formula is that it what? It always works. Always. And always is one of those absolute words. Always? Yeah, always. Today is an exclamation point kind of day. Woo! Okay? It always works. Now, what is it? Okay? X is equal to negative b plus or minus square root of b squared minus 4ac, all of that over 2a. That's the quadratic formula. Beautiful talk, and I'm missing it all. Will 49 divide into 60? No. Will 36 evenly? No. Will 25 evenly? No. Will 16? Will 9? No. Will 4? Yes. Thank goodness. Check this out. Negative 4 times 15 over 6. If you'll do your problems like this, you will not make careless mistakes. Keep leading with that plus minus thing. What's the square root of negative 4, folks? 2i, which goes to the outside. The 15 stays inside because there's not a perfect square that goes into 15. Imaginary number. Whenever we take the square root of a negative number, it gives us that number and I. Okay? What now? Because am I done? Nope. This is like leaving a problem in 2/4. I can simplify the monomials by 2. The monomials being that stuff right there. Do I try to simplify what's underneath the house? No. It is protected. Leave it alone. Okay? Leave it alone. We're going to reduce by 2. So 2 goes into 2 one time. 2 goes into 6 3 times. Plus or minus I root 15 over 3. Holy moly. That's it. In the denominator. For this particular problem, you're never going to see that. But if there were a radical in the denominator, then remember you would rationalize it with that radical over itself, because then we're actually multiplying by 1. Root 3 here. In the denominator, you would multiply root 3 over root 3. Don't change its sign. Yeah. That's something, you'll never see that in these quadratic problems. Okay? Not in the quadratic formula. Folks, do you have other questions? Nope. Bring it on. Bring it on. Okay. Here's what you're going to do. And you're going to work on it now. All right. I want you to notice that 545, we've changed pages, by the way. 17 through 22, I want you to solve by factoring. 29, 30, 32, 36, and 37, I want you to solve by quadratic formula. And then I'm handing you a worksheet where you're only going to do the first 5 problems. Now, folks, only the first 5. Do not mark the rest of these out because you're going to finish them throughout the week. When's your test? 29 through the end. They're all quadratic formula. Two of them, 29 and 37, you better get those right, not because you copied the answer out of the back, but because you're going to check your answer. Yep. All right. And then we got some complex fractions going on for this right here, okay? You may work the rest of the class period. You've got time to knock a lot of this out, okay? Work.